Hey everybody, let's talk about a certain kind of problem that you can solve using Newton's second law. Newton's second law, right, often is represented by um, as an equation more than anything else, but it's really that idea that if you apply a force to a mass, it causes that mass to accelerate. So how might we write Newton's second law? Well, I'm going to write it just over here and say this is Newton's second law of motion. And I'm going to write it down here by saying that this is an acceleration that is caused because a force is being applied to a mass. Now, again, lots of people can write Newton's second laws in different ways, but it's really the relationship between these three variables here. So I write it this way most commonly. Sometimes people write it instead as an F equals ma. That is extremely common. However you would like to write it works fine. There's only one other iteration, which is looking at the mass. And maybe I'll add that one in just for the fun of it and say that mass is equal to, right, a force divided by an acceleration. So that's it. This is all three different ways that you can write Newton's second law, algebraically speaking. We're going to be focusing on one of these three, but let's leave them here for the moment and figure out which one it is. So the problem that I'm going to look at here is that a baseball bat can exert a force of up to 17,793 newtons, which is 4,000 pounds, on a 0.145 kilogram baseball, standard kilogram size of a baseball. And what acceleration can that create in the ball? Remember, an acceleration is a change in velocity. So the ball comes in at a particular speed, and then hits the bat, turns around, and goes out the opposite direction, which is a change in velocity. So that's our acceleration. So let's start out by drawing a picture of our baseball. I'm going to be using DeGuess to be able to solve this. I might not spell out all the pieces as we go, but maybe we'll see. All right, so I'm going to go ahead and draw on my baseball here. So here's my baseball coming in. That's the drawing part of DeGuess. I like to go ahead and give this a little bit more pizzazz here. So here's my baseball, and we've got a few things going in. One is that we've got a force that's on the ball. Now, is this all the forces that are on the ball? No, gravity works on the ball too, which would be down, but at this point in time, that's not really what matters, because I want the baseball bat to be imparting the force on the ball, and that's the only force that I'm worried about at the moment, because I want to know what kind of acceleration does that force provide, right? Yes, it's going to be falling. It falls the moment that the pitcher releases it, and it falls kind of through that whole process. Depending upon the direction that the bat hits the ball, of course, it's going to go against that. But I'm going to focus straight on the bat force here. I'm going to go ahead and drop in my force, and I'm going to call it F, and write in my amount, because this is the G for given in DeGuess, and I'm going to put in my 17,793 newtons, keeping that in mind that I'm working in newtons. And then I'm going to go ahead and drop in my mass as well. I'm going to put that mass in here. M is equal to 0.145 kilograms. Now, this kind of problem is also one of those simple problems that really you wouldn't have to use the whole DeGuess to figure it out. You could just type a few things into a calculator. But as the problems get going, we're going to need more tools to be able to decipher. So I'm going to continue with my DeGuess, making sure that we're good. So I've now drawn my drawing here. I've written in my givens. I'm going to write down my unknown. My unknown, maybe I'll put it right up here, is my acceleration. And my acceleration is the thing that I'm looking for. So that's dgu, all right. And now I need my E. That's my equation. I've got three kind of equations to choose from. They're all the same equation. They're just reworked algebraically. I need the one that seems appropriate here. I know that I've got force and I've got mass, and I'm looking for acceleration. So the one that I want is the one that is solved for acceleration, which is great because that's where we started this whole puzzle. So let's go ahead and write down that equation of acceleration is equal to a force divided by a mass. All right, so now I've got my E for to guess. Now I need my substitute and then solve. Substitute and then solve. So I'm going to go ahead and substitute in the things that I know. So I'm going to say A is equal to, I'm substituting in my force of 17,793 newtons. And I'm going to divide that up by my mass, which is 0.145 kilograms. And this number is less than 1, and this number is quite a large number. So when I solve this for what my acceleration is, I'm going to get a sizable number. All right, so I'm working my way down here. So let's go ahead and take a moment to solve that. So 17,793 divided by 0.145 kilograms. And I'm going to put that in my handy dandy calculator, and I'm going to get this number right here, which is 122,710. And what units am I going to get if I have newtons over kilograms? Newtons divided by kilograms. Newtons divided by kilograms come out actually with a unit of acceleration, where my units of acceleration are meters per second per second. This is my acceleration, and what's amazing about this is that this is a change in velocity of about 80 meters per second. And so how do I know that? Well, because the force on the ball only acts for a little bit of time, we can solve for something like that the next time. So this crazy number of 122,710 meters per second squared is my correct answer here. And that is the acceleration, the change in velocity, right, over time that happens with the baseball. I hope that was a helpful kind of quick rendition. These problems are not that long. It's really kind of rearranging your equation to what you need, plugging what you've got, and then solving it in order to figure out what our accelerations are. All right. I'll see you in the next one. Take care. Bye-bye.